Hi everybody. Today we are focusing the chapter on units. So the three things you need to know. One is base units. Second one is the prefixes. And the third one later I'll run through is equation homogeneity. All right, using the base units as a technique. So let's start off with the base unit first. In your syllabus, there are total 6 base units that you must know. Kilogram, meter, second, and Kelvin. These first 4 are found actually in your datasheet. All right, where you're given a data booklet. From the datasheet, the units that displayed there, you'll be able to derive these 4. The other 2 that are not indicated in the data booklet itself will be your ampere and your mole. Okay. Next, I'll go to prefix. Prefix, this part here, of course, we use the acronym KMGT. So K is actually none other than kilo. So your kilo is 10 to the power of 3. All right. Then it follows by your mega, which is 10 to the power of 6. Giga, which is 10 to the power of 9, and your tera is 10 to the power of 12. Okay. Then you actually have got your milli. So milli is 10 to the power of minus 3. And in the case of micro, is 10 to the power of minus 6. Okay. Then you get your nano, 10 to the power of minus 9. And last but not least, the pico, which is 10 to the power of minus 12. All right. Okay. So all these units, you actually have to memorize it. The prefixes, you have to memorize it and make sure you know it. Okay. So let me give a couple of examples. So for example, if you have 1 TB, okay, the terabyte, that's 10 to the power of minus 12 bytes. So your terabyte will be actually as such, for example. Okay. Another example perhaps to give is your 1 millimeter square. And if you have to convert to meter cube, what do we do? So we can use 1 millimeter times 1 millimeter, which is equal to 10 to the power of minus 3 meter. And we can square them. Okay. So that's how we get 10 to the power of minus 6 meters squared. Okay. So with that, I end the first 2 parts. I'll now get on to look at the equation homogeneity. Right. So for equation homogeneity, there are a couple of typical questions that's always asked. One of which will be as such that if you are looking at the, say for example, the period of a pendulum that's moving, all right, swinging. So let's imagine that. Okay. The factors that could actually affect the period, all right, maybe so it's a function of, say for example, the length, which is your L. Okay. Perhaps the gravity, all right, because the weight would actually have an impact on it, and obviously the mass of the ball may actually have an impact, all right. So it could be 3 factors. So what I could now do is to let T be equal to K, which is none other than just a dimensionless constant. Remember that? So it's a proportionality constant, and it could be L to the power of A, G to the power of B, and M to the power of C. Okay. So we're not very sure about it, but what we could now do is to make use of base units. Okay. So the base unit of your T or your time, all right, is actually in second. Okay. So therefore, if you look at base unit, so on the left hand side, it will not other than be just the second, because that's the time. And on the right hand side, bear in mind that the K, as I mentioned earlier, is a dimensionless constant, so it doesn't have a unit at all. All right. So on the right hand side, you actually get your meter to the power of A because of the length. Okay. And then you got a meter the second squared, which is B, and then you got your kilogram, which is C. All right. So from there, you can do some work on this. So you could make mass and lump it up. So it's A plus B, all right? And so I lumped up the meter together. Okay, one more time. So for the right hand side, this will be as such. This will be the expression. Okay. So from here, I can make sure that the meter are all lumped together. So it is actually equal to meter A plus B, the power of S minus 2B, and kilogram C. Okay. So clearly, by actually understanding the fact that the base unit on the left hand side and right hand side must be equal, we could say that this whole expression itself must therefore be equal to second one, correct? Second to the power 1, because it's the left hand side. So in this case, I can derive that a plus b is now equal to 0, which means a equal to minus b, all right? And from here itself, all right, your minus 2b is equal to 1, so b is equal to minus 1. And obviously your c is 0, okay? Because on the left hand side there isn't any kilogram at all. So hence this is half. So you can see from this quick method that's been used, we can therefore derive T is therefore equal to K L to the power half G to the power minus half. Okay, and this is actually therefore the expression for the period of the pendulum, and as all we can witness, the mass is not a factor that affects